Hello students, welcome back. Am I audible to all? Is my voice loud and clear? Just comment. Okay, so we are going to cover NCERT exercise questions from 17 to 24. A small disclaimer. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experiment. Thank you. So, this exercise is point 2, mainly covering the section 8.4 to 8.5. And in this exercise, we have total questions 32, but we are going to cover in this session from 17 to 24. Now, our question, if the your fourth term of your GP is X, 10th term is Y, and 16th term is Z, then you have to prove that X, Y, Z, all these three terms are in GP. I hope the question is clear. You'll have some seconds to try this problem. Then afterwards we will show you the solution. So just give it a try. So your time starts now. The time is up, and I hope that all of you have tried to prove that the X, Y, Z are in GP, and most of you have succeeded. So, how we are going to prove that the X, Y, Z, these three terms are in GP? So, indeed they are in GP, but how? Solution. Let A be the first term and R be the common ratio of the GP. So A is your first term, simple, and R common ratio. Since from the question fourth term is X, and from that we are getting A4 as AR cube is equals to X, and 10th term is Y already given, then we are getting A10 as A times R raised to the power 9, which is equals to Y. And 16th term is Z, then what we are getting? A16 as A times R raised to the power 15, which is equals to Z. So what we used is the AN is equals to A times R raised to the power n minus 1, where A is your first term of your GP and R represents the common ratio of your GP. So using this relation, AN is equals to A times R raised to the power n minus 1, we are getting A4, A10, A16. Yes? Now, we are using this equation a times r raised to the power 9 is equals to y, and dividing this equation by the equation a times r cube is equals to x. We are going to obtain y by x is equals to a times r raised to the power 9 divided by ar cube. Simple. Or you can rewrite the above equation as, by cancelling the common terms, y by x is equals to r raised to the power 6. Now, dividing a times r raised to the power 15 is equals to z by the equation a times r raised to the power 9 is equals to y, we obtain an equation z by y is equals to a times r raised to the power 15 divided by a times r raised to the power 9. You can cancel the common terms. You will get z by y is equals to r raised to the power 6. Now, you can write y by x is equals to z by y because we have r raised to the power 6 is equals to y by x as well as z by y. So now we know that if the ratio of the second to the first term equals to the ratio of the third term to the second term, that is, common ratio is constant, then the three numbers are in GP. That is, mathematically, second term divided by first is same as third term divided by second, which is same as some constant fixed ratio or number. Thus, you can conclude that your x, y, z are in GP. Clear? Now, this question. What you have to do is find out the sum of first n terms of your sequence. Sequence given to you as first term as 8, second term as 88, third term as 888, fourth term as 4 times 8, and so on, following the same pattern. So just find out the sum. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. Just give it a try. So your time starts now. The time is up, and I hope that everyone has tried. Now, the solution. So simply, in question, we are asked to find out the sum of n terms of your sequence with first term as 8, second term as 88, third term as 888, and fourth term as 8888, and so on. So your sum, which is simply denoted by Sn, is going to be 80 by 81 times 10 raised to the power n minus 1 minus 8 by n times n. How we are getting this as our sum? Let's see. Here's our detailed solution. So starting with the given information, so given sequence is 8, 88, 888, 4 times 8 and so on. This sequence is not a GP. However, we can change this to a geometric series in which every term is forming a GP. How? So first of all, writing the given sequence in series form. So Sn is equals to 8 plus 88 plus 888 plus till n terms. So you are adding how many terms? First n terms of your sequence. Now, you can take 8 by 9 common from the each term and you can write your Sn as 8 by 9 times 9 plus 99 plus 999 plus 9999 till n terms. Clear? Now what we are doing is simply writing our each term 9, 99 as 10 minus 1, 10 square minus 1, 10 cube minus 1 till n terms. What we used? We used, if you are having a number where suppose your number is n digit number and you are having 9 everywhere. Yes, n times 9, then you can write that number is equals to 10 raised to power n minus 1. So using this thing, we can write our Sn as 8 by 9 times 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 till n terms. Now, you can group all the powers of 10 together and all the ones together. So we are getting Sn as 8 by 9 times 10 plus 10 square up to n terms. And another group of 1, we are getting 1 plus 1 plus. So how many ones you are adding? N ones. So from the first group, you are getting this sum 10 plus 10 square plus up to how many terms? N terms. So you are adding these all terms. So this forms a GP, meaning, so this is your geometric series, a finite geometric series. Now, you know that the sum of the first n terms is simply given by Sn, denoted by Sn, which gives you the sum of first n terms of your GP, which is equals to the first term. So whatever your first term of your GP, so first term multiply with the common ratio raised to the power n minus 1 divided by the common ratio minus 1. So you must memorize this formula. Now, as we have observed that the series 10 plus 10 square till n terms is a geometric series, so we can apply our Sn formula here in order to get the sum. So the sum becomes 10 times 10 raised to power n minus 1 divided by 10 minus 1. Why? Because the first term is simply 10 and the common ratio is simply second term divided by the first term. So you will get your common ratio as 10. So both first term as well as the common ratio are the same. So just substituted your values in Sn, you will get the sum as shown in the box. Clear? Now, we also have the other group in which you are adding ones. How many times? N times. So the sum is simply going to be n. Now, using both the results, what we are getting is Sn is equals to 8 by 9 times the first group in which you are adding all the powers of 10, and in second group you are adding all the ones. How many times? N times. So using both the sum, you are getting Sn as 8 by 9 times 10 raised to power n minus 1 divided by 10 minus 1 minus n. And this Sn becomes 8 by 9 times 10 raised to the power n minus 1 divided by 9 minus n. Thus, you will get your final sum as 80 by 81 times 10 raised to the power n minus 1 minus 8 by 9 times n. So this is going to be your sum. Now, this question. Find the sum of the products. So two sequences are given to you. First one is 2, 4, 8, 16, 32. Second sequence is with finite terms 128, 32, 8, 2, half. Simple. You have to find out the sum of the products of the corresponding terms, meaning that you have to find out the sum of the product. So what product? Meaning the first term of your first sequence is going to be product with the first term of your second sequence. So 2 times 128. The second term of your first sequence is going to be product with the second term of the second sequence. And the third term of your first sequence is going to be product with the third term of your second sequence, and so on. And just add all the terms of your product, you will get your sum. So that sum you have to find out. I hope the question is clear. You will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up, and I hope that most of you have tried. Now, in question, you have to find out the sum of the product of the corresponding terms of two sequences. Meaning, you have to product 2 with 128, 4 with 32, 8 with 8, 16 with 2, and 32 with half. And then add all the terms. So the sum is going to be 496. How? Here's a detailed solution. So given information is we are having two sequences. First one is 2, 4, 8, 16, 32. Second one is 128, 32, 8, 2 and half. Now, what we have to find out is the sum of the products of the corresponding terms. So, the required sum becomes what? 2 times 128 plus 4 times 32 plus 8 times 8 plus 16 times 2 plus 32 times half. Here what we did is we product the corresponding terms. Now, the required sum becomes 64 times 4 plus 2 plus 1 plus half plus 1 by 2 raised to power 2 by just taking 64 common. Here, if you focus, the series written in bracket, the each term forms a GP, meaning 4, 2, 1, half and 1 by 2 raised to power 2 is forming a GP. Now, from that, we can say the first term RA is going to be 4 and the common ratio R is simply second term divided by the first. So we are getting our common ratio as 2 by 4. The simplest form is half. It is known that the sum of the first n terms of a GP is simply given by the formula Sn is equals to A times 1 minus r raised to the power n divided by 1 minus r, where a represents your first term and r represents the common ratio. Since a and r, a is 4, r is half. So we are getting, by just substituting, S5 as 4 times 1 minus 1 by 2 raised to power 5 divided by 1 minus 1 by 2. And this expression becomes 4 times 1 minus 1 by 32 divided by 1 by 2, which and this becomes a times 32 minus 1 by 32. And this also and this can be rewritten into this fraction 31 by 4. So S5 is simply 31 by 4. Now, what was our required sum? Quite simple, 64 times this series, this finite series, and we know the sum for this finite series, which is 31 by 4. So we are getting our required sum as 64 times 31 by 4, which gives me 16 times 31, which is 496. So my required sum is 496. I hope the steps are clear. Now, show that the products of the corresponding terms of your sequences. So you are given with two finite sequences. First one is AR square till a times r raised to the power n minus 1. In the first sequence, we are using a and r both small letters. Clear? And these are all how many terms? N terms. Now, another sequence in which we are having first term as capital A, second term as capital A times capital R, till capital A times capital R raised to the power n minus 1. And these are also n number of terms. And both these sequence forms a GP. If you product the corresponding terms, the resultant sequence will also form a GP. So you have to show that the resultant of these products of the corresponding terms also forms a GP, and also find out the common ratio for the resultant sequence. I hope the question is clear. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So just give it a try. So your time starts now. The time is up, and I hope that every one of you have tried. Now, so you have to show the resultant sequence forms a GP, and the resultant sequence you'll get by finding out the corresponding product of your given two sequences. So the common ratio is going to be small r times the capital R. How we are getting this as our common ratio? Here's our detailed solution. So if you product the corresponding terms, you will get your sequence as AR times capital A times capital R, and the nth term as small a times small r raised to the power n minus 1 times capital A times capital R raised to the power n minus 1. And this forms a GP. This you have to prove. Now, how can you show? Quite simple. In order to show, you have to find out the ratios. So ratio First of all, ratio, second term divided by the first. You are just dividing your second term by the first. So second term is small a times small r times capital A times capital R divided by small a times capital A. The common, after cancelling out the common terms, you will get your ratio, the second term divided by the first as small r times the capital R. Another ratio, third term divided by the second. Third term is a small a times small r square times capital A times capital R square divided by small a times small r times capital A times capital R. Cancelling out the common terms, you will get small r times capital R. Now, since the ratio between any two consecutive terms is always end up with the constant thing, which is small r times the capital R. Thus, the above sequence forms a GP and the common ratio is small r times the capital R. I hope these steps are clear. This question, you have to find out 4 numbers which forms a GP, geometric progression, following certain condition. So in your GP, the third term must be greater than the first term by 9 and the second term is greater than the fourth term by 18th. So satisfying these two things, these two conditions, you have to form your GP with 4 terms. I hope this question is clear. You'll have some seconds to try this problem. Then afterwards, we will move on to the solution slide. Just give it a try. So your time starts now. The time is up and I hope you have all tried. Now, you have to form a GP with 4 terms in which the third term must be greater than the first by 9 and the second term is greater than the fourth term by 18th. So using these two conditions. So the GP is going to be 3 minus 6, 12 minus 24. How? Solution. So starting with assuming A as your first term and R your common ratio. So we are getting the first term as A, as we have already assumed. Second term A2 as AR. Third term A3 as AR square. Fourth term A4 as AR cube. Why? Because we know nth term of your GP is simply denoted by an and given by A times R raised to the power n minus 1, where A is your first term and R is your common ratio. From the question, we are given with the third term is greater than the first by 9. So mathematically, A3 your third term is same as A1 your first term plus 9. Or A3 is simply AR square. So we are getting AR square is equals to A plus 9. Or just transferring all A's to the left hand side, taking common, we are getting A times R square minus 1 is equals to 9. Now, from the second condition, the second term is greater than the fourth by 18th. Mathematically, the second term A2 is the fourth term plus 18, A4 plus 18. And we are rewrite this equation as AR is equals to AR cube plus 18, or transferring all the AR terms to the left hand side, we are getting AR times 1 minus R square is equals to 18. Now dividing the equation AR times 1 minus R square is equals to 18 by the equation A times R square minus 1 is equals to 9, we obtain AR times 1 minus R square by A times R square minus 1 is equals to 18 by 9. Cancelling the common terms, we get R is equals to minus 2. Now just substitute R value in the equation AR square is equals to A plus 9. We obtain 4A is equals to A plus 9. Rearranging our terms, we get 3A is equals to 9. Finally, we will get A value as 3. Since the first term is A, second term is AR, third term is AR square, fourth term is AR cube. So just substituting our A and R value, we are getting our first 4 terms of our GP as 3 minus 6, 12 minus 24. I hope these steps are clear. This question, if Pth term of your GP is A, Qth term is B, Rth term is C, then prove that A raised to the power Q minus R times B raised to the power R minus P times C raised to the power P minus Q is 1. You will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. Moving to the solution slide. So in question, you have to prove A raised to the power Q minus R times B raised to the power R minus P times C raised to the power P minus Q is equals to 1, where Pth term is A, Qth term is B and Rth term is C. Quite simple to prove. How? Here's our solution. Assume capital A as the first term and capital R as the common ratio of your GP. Now use the nth term as the first term times the common ratio raised to the power n minus 1. Since Pth term is A, so AP, which is your Pth term, is equals to first term capital A times the common ratio capital R raised to the power P minus 1, which is A given to us. And qth term is B, meaning AQ is equals to capital A times capital R raised to the power Q minus 1 is equals to B. And Rth term is C, then AR is equals to capital A times capital R raised to the power R minus 1 is equals to C, all from the condition. Now, just start with the left hand side. The expression is A raised to the power Q minus R times B raised to the power R minus P times C raised to the power P minus Q. Just substituting our A, B, C values, we are getting capital A raised to the power Q minus R times capital R raised to the power P minus 1 times Q minus R times capital A raised to the power R minus P times capital R raised to the power Q minus 1 times R minus P times capital A raised to the power P minus Q times capital R raised to the power R minus 1 times P minus Q. Just substituted A, B, C values. And this can be rewritten as just collecting all the exponents of A and R. We are getting right hand side expression as A raised to the power Q minus R plus R minus P plus P minus Q times R raised to the power PQ minus PR minus Q plus R plus RQ minus R plus P minus PQ plus PR minus P minus Q R plus Q. Now you'll find out at the right hand side the exponent of A becomes 0 and exponent of R also becomes 0 after cancelling out the common terms because of the negative sign. So you will get A0 as 1 and R0 as also 1. Thus, you will get your answer as A raised to the power Q minus R times B raised to the power R minus P times C raised to the power P minus Q is equals to 1. Hence, proved. I hope these all steps are clear. Now, this question. If the first term of your GP is A, small a, and nth term of your GP is small b, and if P, your capital P, is the product of first n terms, then prove that P square is A times B raised to the power n. I hope the question is clear. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. Just give it a try. So your time starts now. The time is up. Moving to the solution slide. In the question, first term is your small a and the nth term of your GP is small b. Then if P represents your product of first n terms, then prove P square is equals to A times B then whole raised to the power n. Quite simple to prove. How? Here's our solution. So already given the first term as small a and nth term as small b. So the GP simply becomes 8 our first term, second term as AR, third term as AR square, till the nth term as A times R raised to the power n minus 1, where R represents the common ratio. Since the nth term denoted by an is nothing but A times R raised to the power n minus 1, we get B is equals to the nth term. Why? Because we know the nth term is B. So B becomes A times R raised to the power n minus 1. Now from the question, P denotes what? The product of n terms. So P can be rewritten as A times AR square till A times R raised to the power n minus 1. Now grouping all A's and all R exponents together, we are getting two groups. So A getting multiplied with each other and exponent of R getting multiplied with each other. So from the first, how many A's are getting multiplied? N. So we are getting A raised to the power n, and R raised to the power we are getting 1 plus 2 plus till n minus 1. So we are adding how many natural numbers? N minus 1. First n minus 1 natural numbers we are adding. Now, so the exponent of R gives me the terms, gives me an arithmetic progression. So these terms 1, 2 till n minus 1 forms AP. And we know in order to get the sum of my AP, in this particular case 1 plus 2 plus till n minus 1, this becomes n minus 1 by 2 times 2 plus n minus 1 minus 1 times 1. How? Because the first term of your AP plus the second term of your AP plus nth term of your AP, if you are having your AP and you are adding first n terms, and this sum is simply nothing but n divided by 2. N is your number of terms, total meaning first n terms. So n divided by 2 times twice of the first term. So in above the first term is 1. So twice of 1 plus n minus 1. N was what? In the previous, in the above AP, what is our n? Meaning number of terms. We are having number of terms n minus 1. So just replace n by n minus 1 in our formula, this formula, and you will get n minus 1 by 2 times 2 plus n minus 1 minus 1 times 1 as our sum. So this sum 1 plus 2 plus till n minus 1 becomes n minus 1 by 2 times 2 plus n minus 2. Simplifying the right hand side, the expression becomes n times n minus 1 by 2. Now, just using the sum, we are getting P as A raised to the power n times R raised to the power n times n minus 1 by 2. Therefore, P square is equals to A raised to the power 2n times R raised to the power n times n minus 1, or P square is equals to A square times R raised to the power n minus 1, then whole raised to the power n minus 1. Sorry, n. Now, P square is equals to, I am writing A square as A times A. So, this becomes A times R raised to the power n minus 1, then whole expression raised to the power n. This becomes simply P square is equals to A times B whole raised to the power n. Because B is nothing but A times R raised to the power n minus 1. So we are getting our result. So hence proved that P square is A times B raised to the power n. I hope all these steps are clear. Now this question. Show that the ratio of the sum of first n terms of a GP to the sum of the terms from n plus 1th term to the 2nth term is 1 by r raised to the power n. Meaning, first find out the first n terms. Then that sum, divide that sum of first n terms, divide that sum by the sum of what? Sum from the term n plus 1 to 2n term. Then after dividing, you have to show that the ratio, the result ratio, the outcome ratio is going to be 1 by r raised to the power n. I hope the question is clear. You will have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. Now, so you have to show that the sum of first n terms divided by the sum of terms from n plus 1 to 2nth term is 1 by r raised to the power n. Meaning, mathematically, you have to show Sn divided by S2n minus Sn is equals to 1 by Rn. How? Here's our detailed solution. We know that the sum of the first n terms of your GP is simply denoted by Sn and given by A times 1 minus R raised to the power n divided by 1 minus R, where A represents your first term and R represents the common ratio. Therefore, we are getting this sum. What sum? The from n plus 1 term to 2nth term. So this term is simply given by, if you subtract the first n term sum from the first 2n terms, you will get the required sum. Mathematically, S2n minus Sn is going to be the sum of your terms from n plus 1th term to 2nth term. And just using the formula here visible in blue, we are getting S2n as A times 1 minus R raised to power 2n divided by 1 minus R, and Sn as A times 1 minus R raised to power n divided by 1 minus R. Then simplifying the right hand side, this whole thing becomes S2n minus Sn is equals to A times R raised to the power n minus R raised to the power 2n divided by 1 minus R. Now, the ratio, the required ratio Sn by S2n minus Sn, this becomes simply substituting our values. Sn is, just substitute Sn as A times 1 minus R raised to the power n divided by 1 minus R, and S2n minus Sn as A times R raised to the power n minus R raised to the power 2n divided by 1 minus R. This ratio becomes A times 1 minus R raised to the power n divided by 1 minus R. Then complete division divided by, you are getting A times R raised to the power n minus R raised to the power 2n divided by 1 minus R. Just simplify the right hand side. You'll get the right hand side as 1 minus r raised to the power n divided by r raised to the power n minus r raised to the power 2n. Now, you can take r raised to the power n common from the denominator expression and cancel the common terms. The expression becomes 1 by r raised to the power n. You'll get Sn divided by S2n minus Sn is equals to 1 by r raised to the power n, which is your required thing. Hence, you proved. I hope these all steps are clear. So this is it from this session. Thank you.